Alright, moving on to E equals hv. Now E equals hv describes the energy found in a photon, and to get this energy we need to use the Planck's constant, which represents h, multiplied by the frequency, which represents v. Now there's a lot to this formula here. We cannot just use this formula. If the question asks us to find the energy, we will also need to find the frequency. And in order to get the frequency, we will be doing frequency equals speed of light, which was represented by c, multiplied by the wavelength, which is represented by lambda. Now these two formulas have set numbers. Planck's constant has a set number of 6.626 times 10 to the power of 34 joules per second. There we go. And the speed of light is equals to 3.00 times 10 to the power of 8 miles per second. These two are set numbers that are already fixed and will be given to you to find a certain equation. Let's look at an example. We have the yellow light emitted by the sodium lamp in the street light has wavelengths of 589.0 nanometers. What is the frequency of the 589.0 nanometer light? And what is the energy of 1 mole of photons of a yellow light with a wavelength of 589.0 nanometers? Now we need to first figure out what we have. We have we can use the lambda as a wavelength, and we have 589 nanometers and 589 times 10 to the power of 7 meters. We can use this now to get the frequency, which is speed multiplied by the wavelength. So we can do that. So the speed is obviously fixed, which is at 3.00 times 10 to the power of 8 multiplied by 5.89 times 10 to the power of 7, which gives us a frequency of 5.09 times 10 to the power of 14. Now we can insert that into the actual equation, h times v, which is energy equals 6.626 times 10 to the power of minus 34, which is the constant, times 5.09 times 10 to the power of 14, which is the frequency, and that will give us 3.37 times 10 to the power of 19, which gives us the joules per photon, which is the energy of 1 mole of photon. This doesn't usually relate. However, if we want to find out the actual energy, as we can see through the bottom, we have the colors of the spectrum, and we can see that the energy increases from 750 nanometers to 380 nanometers. To find this, we simply have to use the energy that we have last, multiply that by the Avogadro's constant. However, that is not important at this time.